What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today we are back in action prepping you guys for this next upcoming SAT, which will be on June 4th. And that is that. And welcome back. And these are one of my favorite videos ever to do, which is one of the live streams, by the way, where I'm just basically taking the test in real time for the first time. And I'm just making sure my volume is good. So we're all good. And I'm so excited because now it's finally a fresh test has been released. Was able to get it on, and of course, there's only a couple tests a year that the College Board officially releases where I can actually do this and take the test and show you guys and everything. So this is one of those, and this is super cool because I'm doing it live on camera and I've never seen it. So it's all in real time for the first time, right? Like I always kind of like used to do much more regularly, but then I've just sort of taken so many of these tests. So it doesn't happen too often, but one just got released. I want to do it immediately. I'll probably do the calculator section later this week, maybe Wednesday, maybe Thursday, maybe Friday, depending on what I hear from you guys in terms of what would be the best. But anyways, without further ado, this is the April 13th, 2022 test administered this year, the school day test. So probably a lot of you guys that did take it, if you're curious to check it out, we're going to show you now what it's all about. All right, ladies and gentlemen, let's go. We got the timer. This is the no calculator section, so we got the timer set for 25 minutes. What's up, Ron? And we're going to take it, and then we're going to grade it, and then we're going to talk about it briefly before concluding. Barath, what's up? Welcome, guys. I know it's a last-minute stream, so I really appreciate you guys jumping on and being able to watch. So here we go. I'm going to set the timer. What's up, Chris? You're back. All right, here we go. We're going to start the timer at 25 minutes. 3, 2, 1. Let's do it. Okay. The function, if it's defined by 9, okay, what is the slope of the graph? Boom, it's 9/2. That's it. So this is in slope-intercept form, so we can easily see that the slope is whatever's multiplying the x. Boom, done. Number 2. If 2, what's the value of x? Okay, so we're going to solve for x, distribute. We got 2x minus 8 equals x. We're going to subtract 2x from both sides. Boom, boom. We got negative 8 equals negative x, which means x equals, to divide both sides by negative 1, x equals positive 8. Boom. We could have also plugged in if you felt like it, but now we're going to plug in to check. So check it out. 8 minus 4 is 4, and then 2 times 4 does indeed equal 8. Verified, done. Number 3. What is the graph of y equals 3x plus 4? Okay, so it's not this because it's a negative slope, but it's the right y-intercept. This is a positive slope, and it is the right y-intercept, but the slope is wrong because, look, it goes up 2, right, because it's 4, 6, 8. It goes up 2 and then over 6. So that's actually a slope of 1/3, so it's the wrong slope. We need a slope of 3/1, which I'll show you. It's probably this one. This one's wrong because it's a negative slope with the right y-intercept. So this one's right. And it's a little easier to tell here because we can say, like, I'm going up. So this is, again, negative 2. I'm going up 2, 4, 6. I'm going over 2. That's 6/2, rise over 1, run, which reduces to 3. So C is the correct answer, right? Yep. Let me just make sure I didn't look at anything wrong. 3x plus 4. Yepers. Okay, number 4. The graph represents total charges in dollars by a contractor for X hours of work. The contractor charges a one-time fee plus an hourly rate. One-time fee. What is the best interpretation of the slope of the graph? That is the rate, hourly rate. Contractor's hourly rate, not the one-time fee. That's the y-intercept, not the total amount, not the maximum amount that the contractor charges. That makes no sense. Okay, so number 5, here we go. The given equation relates the distinct positive real numbers x, y, and z. Which equation correctly expresses x in terms of y and z? AKA isolate. Multiply both sides by 2y. So I got 2yz equals x plus 3. Then I'm going to subtract 3 from both sides. Boom, that's going to just cancel out. And we got x equals 2yz minus 3. B is the winner. Let me just make sure I didn't make any mistakes. 2yz minus 3. X, yeah, done. Okay, number 6. In the figure shown, ABCD is a parallelogram and EBFD is a square. EBFD. Okay, the area of ABCD is 112. The area of EBFD, the square is 64. What is the length in meters of line segment AE? So we want this line segment. Got it. Okay. So this is a parallelogram. That means these two triangles are equal. And this is an interesting question. So then the next one, that means that the area of these two, because they're equal triangles in a parallelogram like this, it must be 48, right? So each of these are 24 and 24. I'm not sure if this is the best way to do it. This is the first thing that's coming to my mind. They said this is a square, right? And square an area of EB to say, yeah, EBFD is a square. So that means this is 8. This is 8. It's 8 by 8, right? 8 by 8. And that means this length is 6. And I'll tell you why. Because to get the area of a triangle, it's base times height, 6 times 8. We assume these are perpendicular, of course. 6 times 8 is 48. Half of that is 24. So AE is 6. Now, let me just make sure didn't make any mistakes here. So it did say the area of the parallelogram is 112. And just to verify, it's also base of a parallelogram times height. 14 times 8 is 112. That's an interesting question. It's different than, I haven't seen one exactly like that before, or very similar, really. It's cool. All right, function N models the amount of nickel 56 in Earth masses remaining T days after a massive star explodes. About how many Earth masses of nickel were there when the star exploded, aka here, right? So this is time in Earth masses remaining T days after a massive star explodes. So it was 24,000 about. Yeah, because it's 25,000 when it first exploded. Yeah, when it first exploded right here, it was like right under 25,000. Number 8, which of the following pieces of information is sufficient to prove that the triangle ABC is isosceles? They keep doing these proofs, so make sure to catch up on your geometry. So let's draw out a triangle real quick. Hold on. Triangle. Boom. And we'll say A, B, C, whatever. Okay, we need to know it's isosceles. AB is congruent to BC. Yes, that is sufficient. Because if you have two equal sides, it's isosceles. Even if the third side is congruent, that's still isosceles, even though it might be equilateral. So 1 is sufficient. That's wrong. I don't need to cross the whole thing up, but that's wrong. And 2 is sufficient, but 1 is not. That's wrong. So it's whatever. Okay, great. A is congruent to C. Aha. So let's erase this. Angle A is congruent to angle C. This is the isosceles triangle theorem, or the converse of it. I can't remember, but the key is if the two angles are congruent, the sides opposite. They say if angles, then sides. If sides, then angles, whatever. So yes, knowing that two angles are congruent is enough to prove it's isosceles, which means both are sufficient. Number 9. Which expression is equivalent to this? The name of the game here is, of course, factoring, although this is kind of weird the way they've written it out. But I'm going to do what I normally do, which is this is a difference of squares. So I'm going to factor the bottom, 2 plus 3x over. And that's 4 minus 9x squared times 4 plus 9x squared. Because that's a difference of squares. That's a perfect square. That's a perfect square. You square root each. It's plus minus. This is another difference of squares, so I'm going to factor again. Okay, so that's again square root of the difference of squares. 2 plus 3x, 2 minus 3x. And see, by kind of like blindly factoring, when you see something like this, you can see just things happen. Look at this. These two cancel out, right? So now I'm left with 1 over 2 minus 3x times 4 plus 9x squared, which is this one, C. This one just doesn't have the 1 over it, so that's it. Number 10, what are the solutions to a given equation? All right, factor. Oh, no, not factor, because look, you look at the answer choices, they're all in like basically quadratic form from the quadratic formula, so I'm going to use the quadratic formula. Okay, so A, B, C. Negative B, positive 7, plus or minus square root of B squared, negative 7 squared is 49, minus 4A is 3, and C is negative 1 over 2A. 2 times 3 is 6. And then let's simplify 7 plus or minus square root of 49. And then that's the negatives cancel out. It's plus 12 over 6. That's 7 plus or minus 61 over 6. And that's a positive 7. So these negative 7s are out. The 37 is if you forget to, let me make sure I make a mistake, minus 4AC. Yeah, it should be plus. It should be 61, not 37. So B is the winner. Number 11. The graph shows the model. The graph shown models the profit Y in thousands of dollars and the number of products sold X in thousands for a certain company. Which equation represents this model? Okay, so it's a quadratic. We have a vertex at 30, 50, and it's going down, so it should be negative in front of the most significant term. So you're out, And you're going to be out because that's going to be positive. So it's one of these two. And this is in vertex form right here. And it's just reversed, but it would basically be negative 1/18 normally like this times x minus 30 plus 50. And in vertex form, this is saying the vertex is at positive 30 and 50. So you got to make sure you know vertex form, x minus h, squared, x minus h squared plus k. So it's probably this one, but we can double check to make sure, because this one would be wrong, because if you plug 0 in, you can see that the y-intercept would be 50 of this one, but obviously it's 0, 0. So if you plug in 0 to the right one, you should get 0. Also, you plug in 60, you should get 0, which obviously, well, that might work. I don't know what it would be here. 3,600 divided by negative 18 would be like negative 200 or something. No, it would be, negative 200. It would be negative 150. Whereas this one, no reason to do this. I already know, but let's just do it for fun. And it's no calculator, so I have to do it mentally. 60 minus 30 is 30. Oh, and with square. Oh, yeah, I squared it. Okay. 30 squared is 900 over 18 is 50. Yeah, it's negative 50 minus 50 is 0. So we just confirmed it. C is the winner. Done. 12. How many solutions does this equation have? Okay. So let's just simplify. Equals x plus, and then distribute. X plus 2x minus 8, combined like terms. 3x minus 8 equals 3x minus 8. Same thing on both sides, infinitely many, because I can plug in anything for x and it will be the same. Or I can plug in 10, it'll be 22 equals 22. I can plug in 0, negative 8 equals negative 8. Infinite, anything I plug in. 13, which expression is equivalent to this? Okay, we got some exponent rules here. So first, let's evaluate this. I always say with the floating exponent means the multiply the exponent. So the first part, k, 5 to the 16 stays the same. This part, 3 times 5 is 15. 2 times 8 is 16. So it's k to the 5/16 times k to the 5/16. Now we're multiplying these guys, so we add the exponents. So we get k to the 20/16, which reduces to k to the divided both by 4, right? 5/4. But then they put it back in radical form. The numerator is the exponent. The denominator is the radical. So I can say 4th root of k to the 5th power. 4th root b. 4th root of k to the 5th power. You could have also said here 16th root of k to the 20th power, but then it's like you get to that same situation. Like you can actually divide both of these by 4, and this is the most simplified version. All right, nice. 14, a company offers a salespeople 2 different weekly compensation plans. Salespeople in plan X earns 1,000 plus 10%. 10% of their sales. And Y earns 500 plus 0.2 on their sales. Which inequality models the amount in sales each week? Amount in sales each week. D dollars. So let's just go ahead and update. I put X in. Let's put D in. And you see how I'm creating the equation as I'm reading? I find this to be a really helpful strategy. I do it all the time. Sales in each week. D dollars for which salespeople on plan X earn more than plan Y. So this is Y. So we want to know where this earns more. And then we just solve for D. So let's see. I'm going to subtract 5. I don't want to get negative, so I'm going to, just because it's annoying and like there's room for mistake. So I'm going to keep everything positive, is greater than, and then I'm going to subtract 0.1D from both sides. Is greater than 0.2 minus 0.1 is 0.1D. And then I have to divide both sides by 0.1. It's dividing by positives chill because we don't have to flip anything. So it's D is less than 5,000. And they just have it flipped the other way, but it's the same thing. All right, 15. Should I check this? Let me check it. Let's see. So plan X earns more. So, and that makes sense because it should be less than. It shouldn't be greater than, because eventually plan Y will make more because it's a bigger commission, right? A certain number of sales. But for 5,000, you're making 1,000 plus 10% of that, which is 500. So that's 1,500. Here that you're making 500 plus 20% of that. Yeah, that's the break-even point. So that makes sense. What is an equation of the graph shown? Okay, it goes through 0, -1. So I'm going to just plug in 0 for these 0. I'd get 2. or sorry, here I plug in 0 and I get 1 plus 2 is 3 out. Here I plug in 0, I get 2. Here I plug in 0 and I get I get 0 because I get 2 to the 0 is 1 minus 1 is 0. So it's this one. 1 minus 2 is 2. But let's double check other points. I see at 1 at 0, if I plug in 1, it's 2 to the 1, which is 2 minus 2 is 0. And that verifies that. So we're pretty much good. 2 points is all you need. But just for fun, let's check a third point. If I plug in 2, 2 to the second power is 4. 4 minus 2 is 2. Boom. Triple verified. Yeah. Okay. Now we go to 16. The graph of the function f is shown. Okay, so now, again, notice reset in difficulty, right? It's going to get easier because we're on to the free response. The graph of the function f is shown. What is the value of f of 0? So basically they're saying when x is 0, what is the function value? And it's clearly 3 right there, right? Because there's a point 0, comma 3. This is just function notation combined with reading a graph. So 3 is the winner. What is the positive solution to the given equation? All right, I'm going to go old school, plus 2x. I'm going to subtract 4 from both sides. I got minus 3 equals 0, and then I'm going to factor. Boom. So what multiplies to negative 3 and adds to positive 2? That's positive 3 and negative 1, right? And so my two solutions are 1 and negative 3 because negative 3 zeros this out and 1 zeros this out. And we want the positive solution, always positive on the free response. So 1 is the winner, done. And now I'm going to double check by plugging it back in. 1 plus 2 times 1 is 2. 1 plus 2 is 3 plus 1 is 4. Boom, done. 18. The graph line of the xy plane passes through the point 6, 2 and crosses the x-axis at the point 10, 0. The line crosses the y-axis at the point. Okay, what's the y-intercept? That's what they want to know. So I'm going to subtract down and calculate the slope. So the slope is 2 minus 0, which is 2, over 6 minus 10, which is negative 4. So the slope is negative 1/2. Now I'm going to use point slope to get an equation for the line. So I'm going to say, well, I'm going to choose this equation because these are y minus 0. Look at that. So I don't even have to worry about that. Equals negative 1/2 times x minus 10. And this is basically in slope-intercept form. I just have to distribute, and get rid of that. So then I have y equals negative 1/2 x, and then negative 1/2 plus times negative 10 is positive 5. Negatives cancel out. And this is the y-intercept. The b value, or this value right here is the y-intercept. So the answer is 5. Let me make that clear. 5. Circle that. And then if you want to double check, let's see how can double check this just to make sure. We want to know when this is 0. So we can say like this. It drops by 4. This drops by 2. I mean, goes up by 2. Drops by another 4. It would go up by 2 again. And then now we drop by just 2, and this would go up by 1. I don't know if that explanation made sense, like a little bit of a workaround, because it's a linear, it's a constant slope, constant rate of change, but there you go. Number 19, the solution to the given system equation of ordered pair x, y was the value of y. All right, let's use elimination, I think. That's my favorite one. So I'm going to multiply the top. We want y, so let's eliminate the x's. I'll multiply the top one by 4, and I'll multiply the bottom one by 3. All right, so we got negative 12x plus 16y equals 16. On the bottom, we got 12x minus 9y equals 1.5. Add it together. Cancel out. 16y minus 9y is 7y equals, and then we're adding, right? And then 16, that's 17.5. So we divide by 7, divide by 7. Yikes. This is not good because it's a weird fraction. Well, I'm going to double it because I don't like these weird fractions. So I'm going to say it's 35, right? 17.5 times 2 is 35, and that's 14. Then we divide top and bottom by 7, and I get 5 over 2. So we get an improper fraction. It is what it is. You can enter that on the free response. I should probably check this, though, just to make sure. So 5 over 2 is y, and then that's 20 over 2. That's 10 equals 4. Negative 3x plus 10. Negative 3x equals negative 6. X equals 2. So we found 2 and we for x, and we found y. Let's double check. And for the first equation, obviously it works, as that's what we use. So now we check it here. 2 times 4 is 8 minus 3 times 5 over 2 is 15 over 2, which is 7.5. 8 minus 7.5 is 0.5. Boom, verified. Number 20, the equation of a circle is shown. What is the radius? So this is the hardest type of circle problems you're going to get. And when you get it like this, you want to set it up by grouping the y's together first, and we want to get it into vertex form, okay? So not vertex form, into standard form for a circle. So we're going to have to complete the square a little bit. So here I want to take half of 6, which is 3, and square it, which is 9. Half of 5, which is 5 over 2, and square it, which is 25 over 4. But if I do that on the left side, I must do it on the right side as well. So I got to add 9 here and add 25 fourths to keep it balanced. Then I can factor the left side, and you notice I created perfect squares, so now it's x plus 3 squared. And then I have y plus, it is the b over 2, if you're not sure, but it's 5 over 2 squared. And then that equals, okay, negative 45 plus 25 is negative 20 over 4 plus 9. This becomes negative 5, and negative 5 plus 9 is 4. So the radius is the square root of this, which is 2. The center is going to be at, not that we need it, but the center is going to be at negative 3 comma negative 5 over 2. So this equation gives you the center and the radius. And unfortunately, there's not really a way that I can check this. I'm just going to double check my math here. So added 9. Added 25 fourths, that's negative 5. Yeah, I mean, there's not really a way that you can do anything on the non-calculator. You can't graph it, so we're kind of stuck. But assuming we did careful, good work, we're good to go. All right, let's stop the timer, and let's see how we did. Obviously, if this is a real test and you got that much time left, you're going to use every last second, every last minute to double-check, even triple-check your work. But, you know, here it's all good. Okay. We got the answers here. Okay, no calculator. Here we go. The red pen of justice. And we've got DDCA. DDCA. Boom. Nailed it. All right, next. We've got BADCC. BADCC. Yeah. All right, so far so good. No calculator is always my favorite section. If you hadn't noticed, I just think it's just the right length, and yeah, it's fun. Okay, then we have 10 is BCDB. BCDB. So far, so good, right? Make sure I didn't make any mistakes. BCDB. All right, good. And then AD. Yeah. AD. Okay, multiple choices, all correct. Let's go to the free response. Let's see what we got. We got 16 is 3. Then we got 1. Legend. Then we got 5. Yes, we got 5 over 2, or they would have accepted 2.5. And for the win, 2. Yeah. All right. All right, let's see who's all joining now. What's up, Neil Patel? You got 750. Amazing on the May. That's so awesome. Congratulations. Oh, on the May International. Interesting. Who's still waiting for his May results? Ooh, that's a bummer. I remember last time I took it in March, it took an extra week for me to get my results. So I'm just saying, could be something like that. Yeah, I've done it. Oh, for the proof stuff. You know, that's actually a great idea. I'm going to do that this week for the June test, because they keep doing more of these types of proof concepts. I mean, I have done it, by the way, right? Like, I have a whole critical concept series. Here, let me put the video on the link real quick so you can see. It is where is it? It's this one. So this is all the geometry you'll pretty much need. But I think it's a good idea to now address some of these proof problems in particular. That's a great idea because it's a new thing. They're like hitting it hard now. They keep doing it on these tests more recently. So that's a good idea. All right, my friends. Thank you so much for joining. And if you did like this video, please click that like button. All the likes, they really, really help the channel grow. Leave a comment. If you got a question, I'll do my best to get back to you ASAP. If you want to be linked up with one of our amazing, amazing tutors, we now got a team of 11 rock star tutors. Hit us up at tutoring@scalarlearning.com. We got all sorts of price ranges and different experience levels. So we will do what we can and hopefully be able to meet your needs. And of course, you can check out our video course. Our video course is awesome. It's in the link below. And it's only $15 a month, which is pretty stellar. And there's 4 practice tests with video explanations for every single question. It's really for the math section in particular. So you can check that out, sign up, and then cancel anytime. Sign up now and then cancel after a week after you take the SATs. No harm done there if that's all you need it for. So anyways, thank you guys so much. Last but not least, join our Discord community if you haven't done so yet. Our Discord server link is also in the description below. And that's that. I'll be taking the calculator section later this week. Thank you guys so much for joining, and I will see you in the next video. Take it easy.